Hi, and welcome to the Unit 6, Day 6, one-step mole conversion problems. This is the practice step 1. So the purpose of this video is for you to see how to do any of the practice problems if after checking the answer key you're not sure how to do it. So that means that you can feel free to fast forward into the part of the video that deals with the practice problem you have a question about. So just a quick reminder, these are the steps that we do for step 1, which is essentially choosing the right conversion factor. We need to read to identify our given and find, map out a plan to go from our given to our find, and then using either the mole map or just choosing the conversion factor based on the unit, choose the correct conversion factor. And if our conversion factor is the molar mass, we would have to make sure we calculate it using our handy dandy periodic table. Okay, so here, going with problem 1. So the given is, we're given this problem 258 milligrams because that has a number. So grams implies mass, so we're starting with mass, and we're asked to find moles. So we're going from mass to moles. The conversion factor for that will be 1 mole is equal to the molar mass of water. Now, because this is a molecule, I'm going to need to calculate the molar mass from the periodic table. So water is H2O. It's made up of 2 hydrogens, so 2 times 1.01, plus made up of 1 oxygen plus 1 times 16, or just 16. So that's my work here. And then I got the molar mass to be 18.02 grams. So my conversion factor here is 1 mole is equal to 18.02 grams. All right, problem 2. In this problem, we are given 2.5 liters. Remember, liters is a unit for volume, so that's my clue that this is, we're starting with volume. And we're asked how many O2 molecules. So remember, if they say how many molecules or how many atoms, I am literally having to count the number of them, right? So in this case, I'm going from volume to number of particles, specifically number of molecules. So let's go ahead and correct that here. Molecules. Okay, so I'm going from volume to number of molecules. Now, if I go to my mole map, here's my volume, here's my number of particles. There's no arrow that directly connects them, okay? Now, you may be thinking, oh, I can go from here to here. That's next lesson, okay? That would be noticed as 1-2 step. We're just doing 1 step, so there's no 1 arrow that connects them. So because of that, that's a TBD, to be determined. Now, you can go ahead and try if you want to. That would be great if you try. We'll look at these types of problems tomorrow or next lesson. Okay, the next problem, how many moles of O2 are there in 2.50 liter tank? Now, these problems sound very similar, but notice in this case, they're asking how many moles. So I'm trying to find the number of moles, not number of particles, but moles. So I'm finding moles, and I'm given the volume. Once again, I know it's volume because it's in liters. So volume to moles, and in that case, I would use this conversion factor, 1 mole is equal to 22.4 liters. And if you're not sure about that, you're starting with volume, so you find your volume on the mole map. You're trying to get to moles. To do that, you have to pass through 1 mole is equal to 22.4 liters. And that's your conversion factor. All right, last one here. Actually, last couple, I should say. We are given how many molecules are there in 21.6 moles. All right, so I'm given the number of moles, okay, and I can tell because I have a number for that. So I'm given moles, and I'm trying to get to number of molecules. So moles to number of molecules, or more specifically, more generally, particles. So I'm going from moles to particles. If I do that, I have to pass through 1 mole is equal to Avogadro's number. And so my conversion factor is 1 mole is equal to Avogadro's number, or 6.02 times 10 to the 23 molecules. Now, just a quick reminder, for Avogadro's number, the unit will depend on the number of particles you're looking at. Since this is molecules, then it becomes 6.02 times 10 to the 23 molecules. If we were dealing with just carbon atoms, for example, then it will be 6.02 times 10 to the 23 atoms. So these units will match whatever you're given in the problem. All right, last one. We're given, this problem says how much does 4.0 moles of helium gas at STP weigh? So you may be thinking, oh, STP, a gas. Okay, I'm going to be over here, right? There's STP over there. No. STP is just additional information. You don't really need it. Because in this case, what we're given is 4 moles. I know that because I have a number for that for that unit, so 4, so we're going for moles. And they're asking me how much does it weigh. Remember, weigh is a key word for mass. So I'm looking for the mass. I'm going from moles to mass here. So actually in this problem, I would use 1 mole is equal to the molar mass of helium. And for that, I just need to look on the periodic table to find the average atomic mass, which is equal to the molar mass. So that'll be 4. So my conversion factor here is 1 mole is equal to 4 grams, okay, for helium. All right, so that's how we do step 1 for these problems, figuring out the conversion factors. If you haven't watched step 2 in the example problems, go ahead and do that. If you have watched step 2, you can go ahead and start trying to solve using step 2.